Hello, welcome to my third installment on the Convergent NGEN workstation. So I've already done two videos on this. In one video I took apart the CPU and the hard drive module and we looked inside of them. In another video I think I spent some time breaking out the video signals. In this video I'm going to try to run the diagnostics and I'm going to install the Ctos operating system. Now a couple things have changed since the last video. I ditched the power brick that came with it, the old power brick that a bunch of smoke came out of during the previous video. We got rid of that. And here I have a Meanwell LRS 350 I think power supply. Same power supply I use in my Prusa 3D printer and on my lab projects here for my power distribution. This is the 36 volt version of the Meanwell. I have it coming out into an SDL cable that plugs into the back of Convergent. And we have nice, it actually has a fan in there, the fan just kicked on, I can hear it. We have nice, reliable power, there'll be no smoke coming out of this. This is a little bit beefier than the Convergent power brick, so maybe this is equivalent to 1.5 to 2 Convergent power bricks. It should be able to power everything I want to power in one workstation. I have the ability to run 2 cables out of this to power the Convergent NGEN in 2 spots. You're only supposed to run so much power through 1 cable. If I start adding on to this system, I'll run a second cable to power the rest of it. But I can use this Meanwell for all of that. The other thing I did, get this out here to where it can be seen. Whoa! Yeah, loose video cable. So this here is the Breakout Box. Cable comes from the Convergent, the DB25, and we break it out into a 9-pin Monochrome Monitor cable and the keyboard cable, the keyboard via the funky SDL connector. This here is standard 9-pin video signal cable like you'd use on an IBM Monochrome Monitor. You can also use this, as I demonstrated last time, with an MCE to VGA to view on your VGA monitor. So, and in here I have got rid of the original storage media and I have installed an Mfm Emulator because the hard drive that came with this computer was shot. Actually, one of the heads would kind of read, but the other 3 heads, no, they weren't reading very well. The alignment's off. Something's all screwed up with the original hard drive. So we installed the solid-state emulator. And we have installed this GoTech Floppy Emulator, which you can use to load floppy images. It's a lot more convenient when trying out the hundreds of disks of boot media up on bit savers to be able to put them on a little flash drive and flip through them. Finally, you'll see up here we have an actual monochrome monitor. This is an IBM 5151 monitor. I will describe how I got that working in a moment. So anyway, you can't normally just plug a IBM 5151 monitor into a Convergent NGEN. The dot clock is wrong, the vertical and horizontal frequencies are wrong, you could damage your monitor, the vertical sync pulse is the wrong polarity. When I talk about the Breakout Box a little bit, we will get into some of the details of what had to be changed. It is really nice being able to use a vintage computer on the right kind of display technology though. This old green screen monitor looks way better than viewing this emulated on a flat panel. It just looks like it would have looked back in the day.
Okay, here's the schematic for the Convergent Breakout Box that I designed. So over here we have the connector from the Convergent. That's the DB25, and you'll see I put a bunch of jumpers in to allow me to disconnect certain lines, rewire them in case I got something wrong. In the previous video we went through all of the various lines that I found out, lots of grounds, some video stuff, horizontal sync, vertical sync, video and intensity, those are our 4 video lines. We've got 2 keyboard lines here, a serial from keyboard to computer and computer to keyboard. Also a reset for the keyboard. What else? I figured out a couple more things. For example, pin 1 had a speaker. This is sort of a TTL level sound output. You have to run it through a transistor to get sound. So power enable this pin here. When you put ground on that, it will engage the regulator in the Convergent to supply about 30 volts out on this V plus pin. So power enable hooks over here to this jumper to ground. And you'll get the the positive voltage out here to the connector. Now that V plus, 30 volts isn't really useful to us, so over here I have a voltage regulator. This is a standard LM2576. And it will take the 30 volts that comes out of the V plus, pass it through a fuse, and we will regulate it down to plus 5 volts. This power enable and V plus circuit, this is always live even if the computer itself is not turned on. And we don't actually want to engage all this stuff if the computer's not turned on. So I found that there's another pin 2 on the Convergent DB25, that is the power switch. So when that is grounded, the power switch on the CPU has been turned on. So I took that, I ran it down here to the enable bit on the LM2576. The 5 volt goes out a jack in case we want to power any 5 volt stuff, and it also runs a hex inverter. The reason for the hex inverter is primarily that the vertical sync pulse is backwards from what is expected on a standard IBM 5151 monochrome. I wanted to be able to use my 5151 monitor with Convergent, so I have to invert the vertical sync pulse. So we'll see here, VSync goes in here, into hex inverter, comes out, inverted VSync. The rest of this hex inverter stuff is all optional. I kind of gave the option to invert the video horizontal sync. We don't need to do that. I gave the option to buffer all of these, so invert it twice and you get the original signal back. No need to do the buffering. The hex inverter had 5 extra gates, so I tried to put them to use. But primarily used for the hex inverters to invert that vertical sync pulse. Now out here, this is the DB9 to the IBM MDA compatible monitor, so we can use our MC to VGA, or we can actually use an IBM 5151 monitor. All 4 of the lines I brought out here to jumpers so that we can jumper, at least on 3 of them, we can jumper between the inverted signal or the non-inverted signal. So that allows us to invert that vertical sync. No need to ever invert the other 2, but maybe inverting vertical sync is useful to get that IBM compatibility. Only had so many gates, so I didn't have the option to invert the intensity bit. Keyboard stuff is brought out here to the SDL connector, SDL, as well as an 8-pin header. The 8-pin header is useful. If you didn't have the SDL, you could just solder the wires in directly. And then finally, the last thing we have here is the audio output. And I got this by looking at a board I found online that appeared to be some kind of Convergent video breakout board. I kind of tried to figure out the circuit, and what we've got is a speaker that is driven by this transistor here. This is actually a high side switch on the transistor. Speaker goes into the base, will engage the transistor, and connect 5 volt to the high side on the speaker. Have a pin header here in case you want to use an external speaker. So here's the breakout board. It's in a 3D printed case that I made. Let's open it up and take a look inside. So it's straightforward off the schematic. We have the Convergent connector, we have the IBM compatible 9-pin connector, we have the SDL to the keyboard, as well as a pin header that's the same as the SDL. Over here we have our voltage regulator section, our LM2576. It's got its inductor, its capacitor. I put a fuse in here. Fuses are always a good idea. It's an LED that shows that the power is on. Here's the hex inverter. All of the jumpers to let you select inverting those lines or not inverting them. You can see the first one here. I selected invert. That should be the vertical sync. Not much else to it. I think I probably put a jumper in here so that I can unhook the speaker, because sometimes the speaker is annoying. Speaker's mounted here on the bottom side of the board, sticks out the bottom of the case. So like I said, the schematic will be up on my website in case anybody needs to build one of these to make your Convergent computer usable on something other than a Convergent monitor. Now the horizontal sync that this thing produces is not compatible with a monochrome IBM monitor. It produces about 22.2 kilohertz. The IBM monitor is about 18.432, so I thought I would try to mess with the oscillator and see if I could get it to work with an IBM monitor. So this here, what it came with was a 19.8 megahertz. The IBM Monochrome adapter uses a 16.257. So I desoldered the oscillator that was in there. I installed this oscillator socket, and I have a 16.257, the same as what goes in a IBM Monochrome adapter. We will put that in there. We will zip tie it in place so it can't fall out, and we will see what happens. Okay, there are two modern conveniences that I'm going to install just to make working on this computer easier. And these are a Floppy Emulator. This is called a GoTech. You can see the front of it here. It's got a USB jack for plugging in a USB drive, a couple buttons, a display. And what the GoTech does is it allows us to emulate pretty much any floppy drive, you know, from your old 360K to your new 1.4 megabyte, using a little flash drive. And you can store hundreds of images on it, and you can select between them. And it looks just like a floppy drive. So we can plug this in, and we'll get rid of the floppy in favor of having the solid state. Now ordinarily I would prefer to keep the computer original, but as I'm going to be trying out lots of images on this computer, I don't want to have to write every single image to a floppy, run it over, try it out, find out if it does or doesn't work, run it back. This will allow me to put, you know, hundreds of different images on this one emulator and plug this in and have a virtual floppy that I can easily switch disks. The second item is this Mfm Emulator. I found this from plans on the internet, and I'll link that here. And what the Mfm Emulator is, it does two different things. The first is it'll emulate an MFM hard drive via these connectors back here. The hard drive in the Convergent computer was dead. Rather than buy another old MFM hard drive, most of which on eBay are sold as is, condition unknown. Don't really want to take the 40-year-old hard drive gamble, so I will be using this. It is a solid state replacement for the hard drive. So it can emulate a hard drive via over here, and it can, via these headers, it can emulate a controller. So you can use this. If we did have a good hard drive, we could read the data on it, store the data on the emulator, and then plug the emulator in and be able to use the emulator in place of an original hard drive. This thing is pretty well designed. It has a battery backup circuit using these super caps, so that, you know, if you power off your legacy vintage PC, it actually has time to store its data. There's something down here on the bottom called a Beagle Bone Green. I had a little bit of trouble with the Beagle Bone because I'm new to it. Kind of a Raspberry Pi person, not a Beagle Bone person, but I made it work. So anyway, I'm going to mount these two, and we're going to have kind of a solid state storage system in this computer. So here we are booting. You've got the boot up memory test. Now the image I've selected is the B26 Diagnostics disk. Found it on BitSavers. There it goes. It's actually loading from the GoTech. These little dots are the loading sectors off the floppy. I hope that's good and readable on there. A little bit of light coming off of my window. Okay, so there you have it. So it actually has identified the equipment it has. So an 8 megahertz 186 CPU, the Winchester and floppy. It's got a box there for dual floppy. I don't know why it drew that box because I don't have a dual floppy hooked up. It's got a box for keyboard. We do certainly have a keyboard. There's no box for monitor. I'm kind of surprised. I would have thought there would have been some video tests. Let's push a button to continue. And you see we can kind of, I think we can move the cursor keys around.
Yeah, so we can pick which thing we want to test. Let's test the keyboard. You actually have to push the go button, so it's kind of unique. You know, people familiar with a PC, you're not used to having a go button. Actually, we have to push mark, and it kind of colored it, and then we will hit go. Do you want to run the keyboard echo test? Yeah, let's do that. Stop diagnostic on error, sure. Display hex codes, why not? And just run it once. So it did something with the bus. If we push some keys, yeah, that was me pushing the G key, and it sent an E7CD. There's the H key is an E8CD. So there's just various scan codes. Let's try the 1 button. B1CD. So it's doing yeah, it's doing its thing. It seems to be working. Hold finish down. So there's actually a finish key on the keyboard. Holding it down. Good thing about old computers is you can never go wrong by just rebooting them. Okay, let's try a different diagnostic. Let's try the CPU diagnostic. So I'm going to hit mark and go. Stop on a memory error, yep. No, we don't want to run the super long test. And let's just select defaults for all these others. So yeah, it's doing its memory test. I will speed this up. Okay, so it finished the basic diagnostics. I sped that up a little bit because we didn't want to waste a bunch of time on it, but it took it a little while to test memory. There is a more exhaustive memory test you can run. Here it is restarting. I don't know what this debugger not implemented stuff is all about. Okay, next up we're going to do an installation of Ctos version 4 from floppy media onto the emulated hard drive. Here we're booting off of the installation media. Does take it a little while here. It's actually, you can't see the GoTech because the GoTech is located down there off screen, but it's actually reading sectors off the GoTech right now. Pauses sporadically, so I'm saying it's thinking a bit as it's reading. There we go. So I'm assuming this is something installation media version of some sort. It's identified the hardware it thinks it has. It's got a processor, Winchester and floppy, video and keyboard. It thinks the monitor is 12-inch. I don't know how it identifies the size of the monitor. I'm assuming that something in that monitor breakout that I don't quite understand is identifying the type of monitor. So here it's booted up, thinks the date is 1984. Username, you do an installer update, so I'm going to say install. We don't have to set the date, and I will hit the go key. Reading lots and lots of sectors off the GoTech. So here are the initial settings for the volume. I'm going to go in here and I'm going to set surface test to 0 because otherwise it's going to spend a whole long time multiply reading and writing and rereading the hard drive, and we don't need to waste time on that. It's emulated, it will have no errors. So 0 and go. So some varying stuff happening is here is it is copying system software to the from the installation media. Insert disk 2. And press go when ready. New software. Let's just hit go. All else fails, hit go. Insert disk 3. Okay, remove the floppy. We'll do that by just pulling out the flash disk from the Gotek. Let's hit reboot. Let's see what happens. We're doing the memory test again. Now, we don't have a floppy, so we're loading this off of the hard drive. It prints out what it thinks the system configuration is, and look, we're here at the screen. So let's just, we didn't set up a username, so let's just hit go. We'll find ourselves at the command prompt. So if we do help, there's actually a help button on the keyboard. Let me just push the help button, and it'll tell me what all the commands are. So like there's a files command. I've used that one before. So let's, I think if I push help again, it'll tell me detailed information. So yeah, here's all of the various commands that come with it. We can hit next page. Next page. So files display information about each of a list of files, floppy copy, iVolume. Run a diagnostic. Maybe you have to put the diagnostic disk in to do that. Let's see, log out, maintain file. Software installation, that'll let us install stuff from subsequent disks. So let's try volume status. So I actually have to give it a volume name. Let's try D0, I believe is our hard drive. So there, so this is D0, this is our hard drive. It can tell us about this, kind of like running a check disk type thing, except I don't know if it does the check. I think it's just telling us about it. There's when it was created, the number of free pages, the number of free headers, its directory, so it's got a sys directory and it's got a $000 directory. So let's try files. File list. So if we give it no list, it ought to list all files. So if I just hit go, there's a list of all files. Let's do files. What if we tell it we want details? Yes. There, so now it can tell us some stuff about this. So you can see the schema for the volume and directory structure. So I think the bracket is a volume name, so its primary volume is named Win, for not for Windows, for Winchester, I'm guessing. Its directory is sys, and then file name sysimage.sys. So that first file is volume Win, directory sys, and then sysimage, some kind of a system file. Now the runs, those are like .com files, they're executables. So you can see there's in the system directory there's some executables. There's an exec, that's probably the executive. Even the files command ought to be in there someplace. So where's next page? Files.run. So that is the command we're running right now, which is to get the file list. Let's just create a directory. That sounds like fun. Create directory. I'm going to call it Scott, because that's my name. And then if I do files, can we tell it what? In the Scott directory. Oh, can we tell it we want Win? And then we have to give it an asterisk, I think. So that, you know, volume Winchester, subdirectory Scott, and then all files. There are no files. It's an empty directory. Not surprising. Let's get some more help. I thought there was a command to load an editor. Maybe we need to install some more software. Let me try going to the next floppy. Let's do software installation. Let's see what happens then. Well, I don't know. Okay, so it found an installation file on the floppy. Utilities installation. Yeah, let's get some more stuff. Okay, let's see if we might have another disk. Let's try software installation on the next one. Go. Nope, there's stuff there. Editor, yes. Let's install an editor. Okay, remove the floppy. Put it in a safe place. Now if we do help, maybe we've got an editor. Look, we've got an edit command. So let's edit file. We will go in Win Scott. Oops. That's one thing. The angle braces are in a different place on this Convergent keyboard than on a standard PC keyboard. My file. I'll put my name on it. Why not? Scott. Ah, look, an editor. This is my file. If I push the help button, will it tell me? Oh, look, it tells what I can do. Doesn't tell me anything more about it, but I can. There's an everything command. I wonder what that does. Anyway, let's do finish. Finish, save, yes. Go. Now, can we type? Win. Scott. My file. This is my file. So, okay, I managed to create a file. Well, that may be as far as I'm going to go with this little demo. Okay, I hope you've enjoyed going through this rather unique computer from the 1980s, the Convergent NGEN computer, and installing the Ctos version 4 operating system. I'm hoping to do another segment where I will install a newer version of the OS and maybe try out some more interesting things, some more interesting software, and maybe the context switching GUI and stuff that come with it. To do that, I do need resources. You know, installation media would be awesome. It seems to be hard to find reliable installation media. But I do have some really good news. One of my viewers, Joe Altmaier, was an engineer for Convergent back in the day, and he is going to donate me some of his Convergent resources. So some more Convergent computers, including a 286 and a 386 version of this workstation. You see we've got the 186 here, but 286 and 386 will be able to do protected mode. That might allow us to use some of the newer protected mode installation media. Certainly 286 and 386 will be faster. He's also got you know, some stuff like a SCSI disk, lots of cool stuff, power bricks, enough that I could be able to actually set up a clustered installation of multiple computers. We could actually try out the networking features that are built into the Convergent computer. So thank you very much, Joe. When Joe's care package arrives to me, I will be shooting another video, hopefully with some more equipment, and do some even more interesting things.
Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.